All right, next section is 12-1. Today we're going to be learning about cross sections. You can look at this fruit over here that has all been cut with a knife. And when we cut that fruit, it makes a shape. So for example, if you look at this lemon right here, that has been cut so that the cross section is the shape of a circle. Okay, so all we're doing really is looking at how we can cut different shapes to make a cross section and what that looks like. So no numbers today, just shapes and thinking and that kind of thing. All right, so this is representations of three-dimensional figures. You identified parallel planes and intersecting planes way back first semester. Now we're going to talk about the cross sections of them. Okay, so here's a couple examples of a cross section. On the left hand side we have a cone, okay, and there's a plane that's slicing through that cone there. On the right hand side we have Earth, and the cross section there is the equator. So if we were to cut Earth in half, we would have a circle. Okay, we have three different kinds of cuts here. We have the first one, which is called the horizontal cut, which is cut perfectly straight across. If you want to think about that as 180 degrees. The second one is called an angled cut, which is cut at any angle that's not 180 or 90. And then you could say a vertical angle would be perpendicular. So that line at the top of the pyramid here is perpendicular with the base of that face of the pyramid. So those are our three cuts that we're going to look at. Okay, so if we just look at the cone here, and I cut it completely horizontal, like so, with that plane, I get this shape right here. That didn't look good, sorry. But I get that shape right there. I'll highlight it. And that is a circle. Okay, if we cut the cone completely vertically, and then we opened it up and looked inside, we would get a triangle. What if we cut the cone on an angle? As you can see there, if you cut it on an angle, it's not going to be a perfect circle. If it's straight up and down, it's going to be a triangle. In this case, we would say now it is an oval. Okay, so if we look at these different sections here, the first one here, if we cut this straight across on a cylinder, we would say circle. It's the same thing as the base or the top, right? If it's on an angle, right here, we would say oval. And if it's cut perfectly vertical, we would say rectangle. Oops, sorry about that. Okay, describe the cross section of this rectangular prism. First one straight across here is what the base is. So the base is a square. Okay, if you look at this one here, to the right, it is a rectangle. It's cut straight up and down. This one here is also a rectangle. Sorry for my scribble. And over here we can see the cross section. We cut a corner off, and you can see the dotted lines right there. That is a triangle. Okay, so it says sketch the cross section from a vertical slice of each figure. So I'm going to take my pen and go vertical slice. If I can imagine that in my mind, I imagine my circle. Just like if you cut an orange or an apple, well, not an apple, an orange or a lemon or a cantaloupe or something like that. Okay, here, vertical slice. Okay, this one is a little more tricky. If I cut it straight down the middle and I opened it up, it would be, it would be a rectangle. Some of you might say, well, shouldn't it be a trapezoid? Okay, but if we cut it exactly vertical with a vertical plane, okay, the inside of that, if I cut this off here and cut it here, you would see that that would end up being a rectangle. If we went outside of here, it would be a trapezoid. But if you're cutting it down the middle, it's going to be a rectangle. Okay, it says consider the sphere based on the cross section resulting from a horizontal and vertical slice of the sphere, making conjecture about all spherical cross sections. Okay, so all spherical cross sections. If I go here, we know it's going to be a circle. If I go here, we know it's going to be a circle. Okay, if I were to cut both, I would have a circle first, and then if I cut a circle in half again, it's going to be a semicircle. So they're all going to be components of a circle, semicircle or a circle, or even a quarter of a circle. That's it. As always, ask questions if you have them.